Did you know that advanced robot manufacturing has seen a 200% increase in the last 5 years alone? This isn't just a statistic, it's a testament to the remarkable pace at which our world is evolving. Robots are no longer confined to the realm of science fiction. They're here, and they're changing the way we live, one automated process at a time. From intricate assembly lines in automobile factories to precision-based surgical procedures in hospitals, robots have become an integral part of our everyday life. This surge in robot manufacturing is not just about quantity, but also the quality and complexity of these machines. The manufacturing process of these advanced robots is a fascinating journey, one that combines science, technology, and a dash of ingenuity. So what does it take to create these marvels of modern engineering? What goes into the making of a robot that can perhaps outperform human abilities in certain tasks? Stay tuned as we unravel the step-by-step process of advanced robot manufacturing. Every masterpiece begins with a blueprint, and advanced robots are no exception. No matter how futuristic or sophisticated a robot may seem, its journey always begins with a detailed design and blueprint. This is the stage where the magic happens, where abstract ideas are transformed into tangible realities. It's the architect's canvas, the novelist's draft, the composer's score. It is here that we define not only the robot's appearance but also its functionality, structure, and role. Just as a fine art sculpture requires a detailed plan, robots too need a meticulously crafted blueprint. This blueprint is essentially a graphical representation of the robot's structure. It details the arrangement of every gear, every circuit, every mechanical joint, but it goes beyond just physical structure. It also outlines the robot's functionalities, the tasks it will perform, the problems it will solve. Will it be a robot that assists in surgeries, or a robot that ventures into deep space? Each requires a unique blueprint, a unique design. Moreover, the blueprint is not just about the robot's hardware, it also covers the software that will drive the robot. This includes the algorithms that will enable the robot to process information, make decisions, and interact with its environment. It's like the robot's brain, a digital brain crafted with lines of code. In the age of advanced technology where precision is key, we use software to assist in these designs. Software like CAD, or computer-aided design, allows us to create 3D models of our robots. It enables us to visualize our designs, test them, and tweak them until they're just right. This software is our digital drafting table, our virtual workshop. But a blueprint is not just a plan, it's a promise of what technology can achieve, of what we can achieve. It's a testament to human creativity and ambition, to our relentless pursuit of innovation and progress. With the blueprint ready, we move to the next stage, the assembly. The assembly line, where raw materials and intricate components come together to form an advanced robot. In this grand symphony of creation, every instrument plays its part to perfection. Picture a vast orchestra of machinery and human ingenuity, each contributing to the birth of an advanced robot. First, we have the skeletal structure, the robot's body. High-grade metals formed and machined with precision are pieced together like an intricate puzzle. Each part has its place, each joint and hinge meticulously designed for a purpose. Then, onto the assembly line come the motors and gears, the heart of our robot. These are the parts that will give it movement, allowing it to interact with the world around it. Precision is key here. Even a fraction of a millimeter off can mean the difference between a smooth operation and a mechanical hiccup. As the assembly line moves on, we see the integration of sensors, the robot's senses. From cameras that serve as eyes, to microphones for ears, and tactile sensors that mimic the sense of touch. These components allow the robot to perceive and understand its environment. But what about the brain? That's where the central processing unit comes in. This piece of technology is the hub of decision-making, processing inputs from the sensors and translating them into actions. Throughout this process, automation plays a massive role. Robotic arms, conveyor belts, and automated tools work in harmony, tirelessly assembling each robot. Yet in the midst of this mechanical ballet, human supervision is crucial. Skilled technicians monitor every step, ensuring that each component fits perfectly, that every wire is correctly connected. And let's not forget the importance of quality control. Each robot is subject to rigorous checks, ensuring that only the best make it past the assembly line. As the final pieces are put in place, the birth of the robot reaches its climax. But this is only the beginning. The metal and silicon creature that we've assembled is still but an empty shell. Once assembled, we move on to the most critical stage, programming. A robot without programming is like a car without fuel. It's in the programming stage that a robot truly comes to life. Let's dive into the world of robotics programming. This is where the magic happens, where a lifeless machine is imbued with the intelligence to perform complex tasks. In essence, programming is the brain behind the machine, the invisible puppeteer that directs every move, every action of our robot. Programming in robotics is a multifaceted process. It's not just about inputting commands. It's about creating a sophisticated algorithm that can react to a variety of scenarios. It's here that the robot's tasks are defined, its capabilities are determined, and its responses are fine-tuned. Let's imagine our robot is designed for assembly line work. The programming must be precise, enabling the robot to pick up parts, assemble them, and inspect its own work. The robot must know what to do if it encounters a faulty part or if something goes wrong in the assembly process. All of these contingencies are accounted for and programmed into the robot's brain. Now imagine the robot is designed for more complex tasks, like assisting in surgical procedures or navigating through a disaster-stricken area. The programming becomes exponentially more intricate. It must account for a multitude of variables and be able to make split-second decisions. This is where advancements in artificial intelligence, or AI, are revolutionizing robot programming. AI allows robots to learn from their experiences, to adapt to new situations, and to make decisions based on a vast array of data. This isn't just programming, it's creating a learning, evolving machine. AI has opened up new horizons in robot programming, enabling us to create robots that can interact with humans in more natural ways, robots that can navigate through unpredictable environments, and robots that can solve complex problems. With programming complete, our robot is ready for the final stage, testing. This is where we'll see if our programming holds up, if our robot can truly perform the tasks it was designed to do. The moment of truth is at hand. No robot leaves the factory without passing the rigorous testing phase. This is where we ensure perfection. Testing is the stage that separates the machines from the miracles. It's not just about flipping a switch and seeing if the lights come on. It's about putting these mechanical marvels through their paces, pushing their capabilities to the limit to make sure they're ready for anything the world throws at them. Robots are subjected to a variety of tests. Stress tests evaluate their endurance under extreme conditions. Functional tests check if the robot can perform its designated tasks flawlessly. And let's not forget the safety tests, ensuring our new metallic friends pose no danger to their human counterparts. Every test is a hurdle, a challenge to be overcome. With each successful pass, the robot inches closer to perfection, proving its worthiness to join the ranks of advanced robots. And there you have it, an advanced robot, ready to step into the world and revolutionize our lives.